Would you like to know how to create such nice time-lapse videos on a Prusa MK4S 3D printer using a mobile phone and Prusa GPIO Hacker board? If your answer is yes, then continue watching this video. Before we start, I would like to say a few words. I bought the GPIO Hacker board, the Prusa MK4S 3D printer, and all the applications used in this video with my own money. Nobody has any influence on the content of the video and nobody pays me for it. If you want to support my work, you can do so by subscribing here on YouTube, on my social media, and by sharing my videos. In this video, we will be working with a product which is plugged into a printer motherboard. Improper handling can damage not only this product, but more importantly, your 3D printer. Everything you do is at your own risk. I've already shown what a time-lapse video is and what to watch out for in the previous video. Today I will follow up on that video and show you how to create such videos using your mobile phone. Creating a time-lapse video using a mobile phone has made quite a bit of progress over the last few years. Showing you how to create individual frames using, for example, the standard camera app that every phone has would be like going back in time. This is mainly because not every camera app can log the white balance, log the focus on a certain point, and a lot more. Plus, the images from such an app are saved in the gallery with the older photos, where it makes a huge mess. That's why I'm going to focus on more modern methods of creating time-lapse videos. For 3D printing, I was recommended a paid application called PrintLabs. This works by using the phone's microphone to listen for the tone that the 3D printer is supposed to emit by editing the G-code in the slicer. When the app hears the tone, it captures a photo with the selected camera. However, it stores the captured photos in the gallery with the older photos, where it makes a huge mess. You can't adjust the white balance, you can't lock the focus to a certain point, and I could go on like this. It can't create a video from the captured photos, and in fact, the only thing the app solves for us is remote control of the camera shutter. When I think about it, we don't really want to make time-lapse videos. We want to make face animations, which you may know as stop motion. The difference between time-lapse video and stop motion is really just that time-lapse videos should be made at regular intervals, whereas with stop motion it's purely up to us when we capture the next frame. I downloaded and tested the apps you see on the screen. Some were paid and others were free. In the end, I decided on an app called Stop Motion Studio. The free version of Stop Motion Studio offers a full-featured studio for creating stop-motion videos. The advantage of this app is that it keeps the captured images in itself, can put an audio track to them and export the final video file. If you would like to record videos in 4K resolution, you need to pay for the app. The price is perfectly appropriate considering the capabilities of the app. We will take a look at setting up the phone and the app itself before capturing video in a moment. There is one problem that has appeared. While the phone has everything to start capturing, we don't have remote control of the phone shutter. With this app, as with the original camera app, you can use the volume button instead of the shutter button. This app has an option in the settings to enable or disable the use of the remote shutter release. That's when a crazy idea popped in my head. I thought of using the ESP32C3 and programming it as a Bluetooth button for volume control or for pressing the shutter release. Unfortunately, Apple is a bit different than Android in this and doesn't like using similar Bluetooth devices. As a result, I'm left with this pile of misery that I bought for this video. If you want to help me make my loss not so big and painful, click the like button below this video and subscribe to my YouTube channel. In the meantime, I will tell you how I decided to solve the problem. At home, I had this Bluetooth button directly designed for triggering the camera shutter of my phone. However, it had one huge flaw. That was that after a certain period of non-use, it automatically switched off. Therefore, I had to look around for a variant of the button that doesn't have an automatic shut-off. In the end, I decided to invest in this incredibly cheap variant of the Bluetooth button. After turning on and pairing the Bluetooth button with my phone, I tested it along with the app. As you can see, the trigger control worked without a single issue and it didn't matter which button I pressed. With the new toy, there were new problems to solve. We now have an app to create videos and also a way to control the phone's trigger remotely. This button works as it should, but we want to control it with the printer. To do this, it needed to be slightly modified. If you have the same version of the button at home, but from a different company, you have nothing to worry about. I will try to explain the procedure as universally as possible. First, the Bluetooth button had to be opened and looked inside. To do this, it was enough to lift the front cover with a sharp object. As you can see, the two versions are very similar. However, the new version is much simpler and easy to understand. On this circuit board, you can see the sliding power switch and these two buttons. From the previous test, you probably already know which of these buttons works with your phone. In my case, both buttons work, so I can choose. In order to simulate pressing the button remotely, I decided to connect two wires to the button. The button has two true contacts that connect when it is pressed, so you only need to solder the wires to one side. Using a multimeter, I verified which contacts were true and which wires needed to be soldered. If you don't have a multimeter, you can use metal tweezers. However, this test needs to be done with the button powered on and paired. If you do have a multimeter, you can try checking to see if your button leads to any of the control points or to a common ground. This can actually make your job a lot easier. In my case, both the lower and upper buttons were leading to control points and common ground. So I just soldered one wire to the common ground and one wire to the control point. Remember which wire led to common ground. You will need that later. If you don't have a multimeter and don't want to complicate your work, just solder the two wires to the push button and test that everything works as it should. These two wires will be used to communicate with the Prusa GPIO hacker board. Now we need to solve another problem, and that is the stable power supply for this button. While looking for a way to power both of these remotes, I was thinking how nice it would be if I could use one of the old USB chargers I had a bambillion of at home. However, there was one problem. The battery that powers these Bluetooth buttons is only 3 volts, whereas most USB chargers deliver 5 volts. I decided to play tough guy. I soldered the black wire from the USB cable to a common ground and the red wire to the positive power pin of the battery. You can also solder these wires to the control pins. Some USB cables may contain wires of older colors. Always check which wires are the power wires and what their polarity is. I closed my eyes and slowly pushed the USB cable into the charger. I expected a loud bang and lots of smoke. Instead, the button turned on normally and worked without any problems. I realized that some sort of biasing resistor certainly wouldn't hurt, but if it works, why change it? With power from an external source, there was no longer a need for this sliding power switch. So I switched the switch to the on position, and instead of using the extension on the switch, I used this hole to lead the wires out of the device. There must not be a battery in the Bluetooth button if it is powered by an external source. This could cause the battery to explode. Now, all I had to do was put this whole creation together and sort out the last little detail. Now we need to solve controlling the Bluetooth button using the printer. To make it as easy as possible, I added a double DuPont connector to the two wires. Instead of the DuPont connector, you can use a 3 or 4 pole jack 2.5 mm. I connected this connector between pins ground and 0. Instead of pin 0, you can use any pin from the open drain section. It is important that the wire connected to the common ground of the Bluetooth button is connected to the common ground of the Prusa GPIO hacker board. If you wire it incorrectly, the trigger button will remain on and cannot be used. To simulate pressing the button, just turn on the printer with the Prusa GPIO hacker board connected. Using the console and on-screen commands, I ran a test. These commands set pin 0 to output. The pin 0 will switch to the high state and then immediately to the low state. This will simulate a button press and release. However, while testing this Bluetooth button, I ran into a problem where the phone failed to register the command to capture a picture. Therefore, I added a delay of 200 milliseconds after the button was pressed to the command. That solved the problem. In the previous video, I showed the configuration of Prusa Slicer for creating time-lapse videos. In this video, we will use this configuration as well, but we need to add that pause I mentioned a moment ago to the G-code commands to capture the frame. Combining the information from the last video and this video, we actually go to the finish. In the slicer, we will prepare the model according to the previous video and send it to the printer for printing. In order to know where the model will be during the image capture, we can use a little trick to do this. In the G-code, I use the X and Y position for creating the time-lapse video, which is used by the printer after the print is finished, but also after the print is cancelled. So just wait for the printer to print the first layer and then cancel the print. To have something to focus the phone's camera on, you need to place an object on the print pad instead of the printed model that matches the printed model in size and, if possible, also in shape. The Bluetooth button must be connected to a power source and connected to the Prusa GPIO hacker board. And of course paired with the phone. Before we start capturing individual frames, we need to prepare the phone. You need to turn off the automatic screen lock on your phone. If the phone is actively in use, I recommend turning on airplane mode to avoid interrupting the capturing of frames. The phone should be connected to a power source to prevent it from being discharged. Lastly, keep the position of the phone stable and unchanging during printing. For this, any stable stand from which the phone has a view to the printing area will be enough. After opening the app, just click on the button with the text New Movie and then click on the button with the camera icon. This will take you into the mode of capturing individual frames. Before capturing frames, I recommend going into the settings and setting the mode to AL. In this mode, there is no autofocus and no automatic exposure correction. This keeps the video in the same focus with no change in brightness, contrast or color in general. Tap the screen to lock the video color temperature and focus on that subject. After that, I would recommend going into the menu to manual mode where you can fine-tune the look of the captured frames. Probably the most important parameter is the shutter speed. Here I set 150 because in our country we have AC voltage at 50 Hz. Thanks to this, there will be no artifacts in individual frames. The rest of the parameters, such as color temperature, are purely in your control. This brings us to the point where we are ready to record our first video. So just clean the print pad and start printing again. But this time without interruption. If you have got everything wired correctly, the button should flash on each layer and the camera sound should be heard. I mean, if you have your phone sounds turned on. Once the printing is done and so is our recording, it's time to export the video. Before exporting the video, I recommend changing the frame rate. This way you get a video that will be more enjoyable to watch. To export the video, we need to go back to the home screen of the program and long-click on our project. From here, it is up to you what you want to do with the video. If you are interested in learning how to create the same time-lapse videos while printing with your DSLR camera, give this video a thumbs up and subscribe.